Starting with the first question. In first question, they are asking you to identify the physical quantity. So physical quantity must have two properties. One is it must have a magnitude, that is simply number, plus it should have a unit. Okay, so it's option C, that have magnitude and unit as well. In the second question, they have given us this equation in which we know the units of t and unit of t. We have to find unit of b and c. So the equation is 1 over t is equals to b over under root d plus c. So first we have to make c or b the subject. So let's make the c subject of the equation. It will be 1 over t minus b over under root d. Taking LCM, we will get under root d minus bt divided by t under root d. Okay, so now let's put the unit. We know the units of d is equals to m square, so c is equals to m square minus b. For t it's second and t is second under root m square. It will give you m minus bs divided by ms. Okay, so this we have, if you see in the numerator, it's m minus bs. So if this first quantity, this m, if have to be subtracted from this bs should also be equals to m. So I can say that b must be equals to m over s. Okay, so b is m over s. We get this value, and putting this value in this equation will become m minus, for b it is m over s, and multiply by s divided by ms. So it will be s divided by s is m divided by ms. This m will be cancelled out over 1 over s. So this is the value of c. So c is s minus 1 and b is meter per second. So it's option B. Okay. In the third question, a hollow cylinder which is open at the both end has a radius of, this is the value of the radius and this is the value of the length. What is the value, whether it's absolute uncertainty of the surface area of the cylinder? So first of all, we should know about the formula for the surface area. Surface area of cylinder is surface area is equals to circumference multiply with the length. So this will be 2 pi r into L. Putting the values, 2 pi r is 3 and L is 15. So multiplying all these values, we will get 2.6 centimeter square. Okay, so now let's work on the uncertainty. So first of all, as the L and R are multiplying with each other, so uncertain, first of all we have to find the percentage uncertainty of the area, then we can find the absolute uncertainty. The percentage uncertainty of A is equals to percentage uncertainty of R plus percentage uncertainty of L. Okay, so this will be the equation. So percentage uncertainty of L will be we have to the uncertainty divided by the magnet value. Least count divided by magnet value, it's 0.1 divided by 3 multiplied by 100 plus 0.1 divided by 15 multiplied by 100. So this will give you 3.99%. So there is a 3.99% uncertainty in area, and area was, the value of the area was this 2 something, so it's 282.6. okay, so 3.99 multiplied by 282.6 divided by 100 will give you the percentage, will give you the absolute uncertainty. Okay, it will be 11.27. okay, that is the 3.99% of 282.6. so the final answer we can write it as area is equals to, this is the uncertainty and this is the area, is equals to 282.6 plus minus 11.27 centimeter square. So it's option B. Sorry, it's option A. A is the closest one, okay? So it's option A. In question number 4, a snooker ball of mass 0.20 kg has a collision so that the direction of the movement of the change by the 90-degree angle. Okay, so initially the ball is moving in the rightward direction, then it's moving upward. We have to find the magnitude of the change in momentum. So first of all, we need to understand that momentum is a vector quantity. So initial momentum was this is the initial momentum, and after colliding its momentum will be in this direction. So the resultant momentum will be by applying head to tail rule, it will be in this direction. This will give you the change. Okay, so we can find the magnitude by this, applying the head to tail rule, Pythagoras theorem. We can find the magnitude. It simply equals to momentum in the x axis square plus momentum in the y axis square and square the root. So it will be equals to p I square plus p f square. P is basically momentum is mass into volume. Okay, so for pi will be mass is 0.20 and initial speed was 0.40, and pf will be mass is same and the final speed is 0.30. so applying this here, 0.20 into 0.40 square plus 0.20 into 0.30 square, that will give you 0.10 kg meter per second. That is the final momentum. So it's option B is the right one. Okay, so in question number 5, a ball is kicked upward at an angle of 45 to the horizontal ground. After a short flight, the ball returned to the ground. It may be assumed the air resistance is negligible, but is never zero during the flight of the ball. Okay, so let's consider a projectile motion. Let's suppose the ball was initially at this point, and this is, let's suppose, ground, and the ball will move like this, and it will land at some particular point. Okay, so when the ball move, it will start move. It will have The velocity is in direction. This is the velocity. This is the horizontal component. This is the vertical component. And we know that during the journey, the vertical component will decrease, but the horizontal component will remain. And the maximum height, the vertical component is 0 and the horizontal component of the velocity remains same. And when it move downward, the vertical component will again start increasing and the horizontal component will remain same. So it is the horizontal component of the velocity that will remain same during the complete journey in the projectile. So it's option B. In question number 6, the graph shows the variation with time of displacement s of the object. Which graph represents the variation with time t of the acceleration of the object? Okay, so we should know it's a distance time graph. So slope of s and t represents velocity. Okay, so if you consider this is a constant slope, this is a constant slope, so these green lines are showing you a constant velocities. And if you see this point, the velocity is changing. At this point the velocity is changing, so this is basically change in velocity. Okay, so these red points are, so when the change in velocity is there will be it will lead to acceleration. So at this point there is only acceleration. So if we see the graph, it's not the case of decreasing acceleration, it's not the best fit, not that one, this one is right. Because why? When during the green patches, if you compare the upper graph and the lower one, here during the green patches the acceleration is 0, and at the red points the acceleration is suddenly maximum. Then again velocity is constant, acceleration is 0, then again we have acceleration, and then again the velocity is constant, acceleration is 0, and when the velocity will change, acceleration is will have some value. And if you see, there is at these points, if let me, at these points there is a decrease in velocity, so it's a negative acceleration that is shown here. Okay, and at this point there is a increase in velocity, okay, so it's a positive change, it's positive acceleration that is shown at this point. Okay, question 7, which expression defines force? So force can be defined as change in momentum divided by time. It's called rate of change of momentum, so it's option C simply. Okay, sorry, it's option rate of change of momentum is option D. Basically it's not multiplied, it divided. Okay, it's option D. Question 8, a ship of mass is approaching a harbor with speed of 16.4 by using reverse thrust. It can maintain a constant total stopping force of this. How long will it take to stop? Okay, so basically there is a acceleration and the mass is also given, so resultant force by the Newton's second law is equals to ma. We need to apply same force to stop it. Okay, so resultant force must be equals to the stopping force, that is equals to 92000 newtons. So m is given, that is 8.4 into 10 raised to power 7 kg. Acceleration is unknown. Acceleration is basically v minus u divided by t is equals to this value. It's finally going to stop, so final velocity will be 0. Initial velocity is we have to, this is the initial velocity, so it will be ignoring the minus sign for the timing because time cannot be minus, so it will be 8.4 into 10 raised to power 7 is equals to 0 minus 16.4 divided by t is equals to 920. Okay, so t will be equals to 8.4 10 raised to power 7 into 16.4 divided by 920. Okay, it will give you will get answer 1480 seconds. Okay, so no option is matching this one, so we can convert it into minutes. Converting this time into minutes, we have to divide it by 60. That will be 25 minutes. It's option C. In question 9, the velocity time graph for 4 different objects are shown. Which graph represent an object falling from the rest through a long distance in the Earth atmosphere? Okay, so if the distance is, first of all, it is moving through the Earth atmosphere, so there will be a air resistance. So this cannot be a case, okay, because there is a constant acceleration. This is velocity is constant. This is also not possible because velocity will increase. This is the increasing acceleration. This is also not a case of free fall. This is the case. That is a free fall motion in the presence of air resistance when the object is falling from a great height. The 10th question, which statement about collision is correct? Kinetic energy is conserved in all the collision. No, kinetic energy is only conserved in elastic collision. Momentum is only conserved in momentum is conserved in all the collisions. Okay, and see, the relative speed of approaching is equals to the relative speed of separation for the perfectly elastic collision. This is correct one. Okay, option C.